There are two methods of representing a set. First one being the roster method or tabular form, here in which we list out the elements. The second being the rule method or set builder form, where we write the properties. Let us discuss the two methods of representing a set in detail. The first method, which is roster form. Here the elements of a set are listed and the elements are being separated by commas and they are enclosed within braces or flower bracket. Example, here we see the capital A, which is the name of a set, and the elements which it contains are written in flower brackets, that is 1, 2, 3, 6. Let us remember that the order of these elements which are written is immaterial, means it doesn't matter. See, again I have written the same set, but this time the order of the elements is different from the previous. 1, 2, 3, 6 is written as 3, 1, 2, 6, 2. However, both the sets are same. There is no difference between the sets. Both we consider as the same set. Even if I write it in a totally new way, that is 6, 3, 2, 1, the elements being the same but written in different order is not considered as the different set but the same set. Let us take one more example here. I am taking the vowels of English alphabet. The vowels are A, E, I, O, U. However, if you try to write it in a different order, I am writing here is I, U, E, A, O. Again, it remains the same set P. The name does not change because the order is immaterial. Let us try to write it in another way, that is U, O, I, E, A. Again, I am talking about the same set P because the order is immaterial. It does not matter in which order you write the elements as long as the elements remain same. The set remains same. Few more examples of how to write a set in roster form. Here, set O is written as 1, 3, 5, 7. We can read it as set O contains 1, 3, 5, 7. Set B contains V, I, B, G, Y, O, R. These are the colors of the rainbow which we have already discussed in some previous examples. So that is B is equal to V, I, B, G, Y, O, R, or B contains V, I, B, G, Y, O, R. Another set M, which is equal to noun, adjective, pronoun, verb, adverb, preposition, conjunction, interjection. These are nothing but the parts of speech. We say that M is a set of noun, adjective, pronoun, verb, adverb, preposition, conjunction and interjection. Here I am mentioning all of the parts by their name. I am listing them out. This is called as roster method. One more thing to concentrate is the elements are not repeated. For example, if I take the letters of the word Malayalam, if I write it as a set C, then we will write only the distinct ones. We will not repeat. First one being M, second one being A, I have written as A, third one is L, I have written L, fourth one is A, which is already written, so it will not be rewritten once more. Y, it's a new letter, so I write it again Y. Again A, which will not be written, already written there, will not be repeated. L again, repeated, so won't be written. A, repeated, so won't be written. M has already been written, so won't be repeated again. So the four distinct letters M, A, L, Y are the only elements written from this set. So this is how a roster form looks like. Now one more example. I am taking the word potato. Now how do you write potato? The letters of the word potato in the set. Here set D contains P, O, T, A. However, the last T and O is not repeated because in roster form we will not write the elements once again or it will not be repeated. I take one more last example. The word is committee. if you write the letters of the word committee in a set, that will be set E contains C, O, M. However, the second M is omitted here. It is not written. I being a new letter, it is written. T written only once because out of the two T's that you see here, only one will be written. The other one will not be repeated. And E is repeated twice in the word. However, in the set, it is written only once. So you find that the letters are not repeated. So we understand two things from this. In roster method, when we write, we do not give importance to the order in which the letters are written. So according to us, if you write ABC or ACB or CBA or CAB or BAC or BCA, all of them are same because order does not matter. And the second thing to remember, the elements will not be repeated. Coming to the second form, that is set builder form. All the elements of a set possess a single common property, which is not possessed by any element outside the set. That is called as set builder form. In other words, we write them as their properties and not the elements themselves. So it may be seen that you will describe the element of a set by using any symbol like X or any other symbol for that matter, any small letter or lowercase letter from English like small a, b, c or x, y, z or p, q or anything can be used, which will be then followed by a colon. Colon is the double dot vertically written one above the other. That's colon from the punctuation marks that is used. After that sign of the colon, we write the characteristic property possessed by all the elements of the set. Then enclose the whole description within braces. Again, flower brackets comes into picture. For those who could not exactly picturize what I just said now, we will go with some examples. First example, see here. A is equal to, first as I told you, one letter is used, right? That is X is used here. Not compulsory. You can use other letters also, but in small letters or lowercase letters. Then the colon, yes. Then we say X is a factor of 6, which is the property of the particular X. So we can read it as A is a set of all X such that X is a factor of 6. I repeat, please concentrate on the left side here. A is equal to, we'll read it as A is a set of all. So the equal to symbol is read as A is a set of all X. And the colon is read as such that. Colon is read as such that. Such that X is a factor of 6. And whole thing about the X and the property, it is written within the flower brackets or braces. One more example we take here. P is equal to flower bracket Y colon. Y is a vowel in English alphabet. How do you read this now? P is a set of all Y such that Y is a vowel in English alphabet. Please follow the pointer carefully so you understand how it is written and how it is read. So here you see O is the new set. Let me read it how it should be read. O is a set of all Z such that Z is an odd natural number. Easy, I suppose. Let's go to one more example. B is a set of all X such that X is a color of the rainbow. Similarly, last but not the least, one more example I am taking here. M is a set of all Y. Let me remind you, you can take any letters X, Y, Z or P, Q, R, A, B, C, any of the letters. So Y such that Y is among the parts of speech. Now that we have learnt about the two methods of representation, let us see how to convert from one form of representation to another form. Here one example is there. Write the following in roster method, means the given form is rule method or set builder method. Here it is given as set A is a set of all X such that X square plus 5X plus 6 equal to 0. What do you mean by this? X square plus 5x plus 6 is equal to 0 is a quadratic equation. Then what does x mean here? See, it is a quadratic equation with x as the variable. If we solve, we will get two values of x. Those two will be the elements of the set A. So let us try to solve the quadratic equation. We will be using factorization method in this example. I hope you remember. 5x is split as 3x plus 2x. Next step, x is taken common out from the first two. 2 is taken common out from the next two. So we get x into x plus 3 plus 2 into x plus 3. So x plus 3 is common. We take that out. We get x plus 3 into x plus 2 is equal to 0. So what do you mean by product of two numbers is 0? Either the first one should be 0, that is x plus 3 should be 0, which indicates x should be equal to minus 3. How? Plus 3 comes to the other side, becomes minus 3. So one value of x we got, that is minus 3. Or the product is equal to 0 also means the second part must be 0, that is x plus 2 should be 0. If x plus 2 is 0, then automatically x is equal to minus 2. Why? Because plus 2 comes to the other side, becomes minus 2. We got two options here, minus 3 or minus 2. These are the two values to be written in roster form. Let us see how to write them. Therefore, in roster form we write set A is a set of which contains minus 3 and minus 2. Pardon me, let me repeat. A is a set of minus 3 and minus 2. We can also say A contains minus 3 and minus 2. Another example, write B is a set of all x such that x is a positive integer and x square is less than 40 in roster form. Means the given one is again in rule method or rule form or set builder form. So the property of x is given that when squared it should be less than 40. All those numbers when squared, and it's also an integer, when squared it should be less than 40. Let us also give importance to this part, that is positive integer, which indirectly means natural number. So I am taking all the natural numbers possible, that is x is equal to 1. If x is equal to 1, let us see if it can hold true to this condition given. So I square x, it becomes 1. X square is 1. So if x square is 1, is it lesser than 40? Yes, of course. So that means x equal to 1 is the value of the element which is present in B. If x equal to 2, then its square must be 4. Is the square of the number less than 40? Yes, of course. That means 2 also belongs to B. So we got two elements in B, 1 and 2. Let's continue with 3. 3 square is 9. So again lesser than 40. Again 4. So 4 square is 16. Again it is less than 40. That means all these numbers 1, 2, 3, 4 till now belong to the set B. What about 5? Yes, of course, its square is 25. Still lesser than 40. How about 6? Very, very nice. 36, which is the square of 6, is again less than 40. That means this is also an element of set B. However, if I take the next number, that is 7, when squared becomes 49, which is not lesser than 40. Please concentrate here. 49 is not lesser than 40, it's greater. That means 7 does not belong to B. We are not talking about the squares here. We are talking about the element. When squared, it should be less than 40. So, don't look at 1, 4, 9, 16. They are squared numbers. But we want that root number, which is 1, 2, 3, 4, 5, 6. These are the numbers which hold true to this condition, that when they are squared, they are lesser than 40. So, B will be written as, in roster form, B set of 1, 2, 3, 4, 5, 6. All the other numbers other than these are surely to give you squares which are greater than 40. So I hope it's clear that we can convert the set builder form into roster form. Here I take another example, but this time the reverse case. Write the following in set builder form. A is equal to 3, 6, 9, 12, 15 means A is a set containing 3, 6, 9, 12, 15. So I am already looking at these elements directly separated with commas, right? That means this is a roster form. Let's try to find out that one property that will hold good for all these elements but not for the elements outside these. See, the numbers given are all multiples of 3. Very clear, isn't it? So we can write them as 3 ones are, 3 twos are, 3 threes are, 3 fours are, 3 fives are. These are the numbers which we see inside set A. However, if you observe, the general form of all these above numbers must be 3 into n, where n is replaced with this 1, 2, 3, 4, 5. There is a constant number in all these, that is 3. So we keep 3 in its place, and n takes up all the values, that is 1, 2, 3, 4, 5. So which are all natural numbers up to 5 less than 6. 1, 2, 3, 4, 5 are all natural numbers. Up to 5 you can say, or less than 6. So hence we can say two things mathematically using symbols. N should be strictly less than 6. Right? 1, 2, 3, 4, 5 are all strictly less than 6. Or we can say n is less than or equal to 5. Because there are two conditions here. All the numbers less than 5 and also equal to 5. All of them can be mentioned. Which are those? Lesser than 5 is 1, 2, 3, 4. And equal to 5 is 5 itself. So the numbers are same. 1, 2, 3, 4, 5. So n's value are from 1, 2, 3, 4, 5. So now using this knowledge we can write A is a set of all x. Let me remind you that we can use x, y, z, any letter. I am using here x. Just a convention. A is a set of all x such that x is equal to 3n. Means x can be written in the form 3 into something, where that something must be less than 6 and also belong to n. That small letter n stands for a number which is less than 6 but also at the same time belongs to natural number. Or we could say that A is a set of all x such that x is equal to 3n and n is less than or equal to 5. See, I have replaced strictly less than 6 with less than or equal to 5. And again, n should belong to capital N, means it should be a natural number. Let us come to the last example, that is example 4. Write the following in set builder form, means the one given is in roster form. We see the elements 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. There is a connection between the numerator and denominator. Let us try to break the code. These numbers can also be written in another form, that is 2 upon, instead of 3 we can write it as 2 plus 1, because 3 is an increment of 1 than 2, right? It is when 2 is incremented by 1 we get 3. Similarly, the next fraction 3 upon 4 can be written as 3 upon 4 can be written as 3 plus 1. So 1 more than 3. Similarly, the next 4 upon 5 is 4 upon 4 plus 1. 5 upon 6 is 5 upon 5 plus 1. 6 upon 7 can be written as 6 upon 6 plus 1. Hence, any variable we can consider, for example, x or y or z. I told you these elements can be used to show the elements in rule method or set builder form. I am using y here arbitrarily. Now y is equal to n upon n plus 1. Many of you will wonder, why did you suddenly take this? See, the relation between the numerator and denominator is such that any number you take in the numerator, denominator should be plus 1 more than the numerator. So I take n. You could take m or any other letter. I am just taking n because it's a natural number that we are seeing in the numerator and denominator. So I have used n here. So n is a number in the numerator. The denominator will be 1 more than n. So we can write it as n upon n plus 1. Right? And also these n values, if you observe 2, 3, 4, 5, 6, they are greater than 1. However, they are lesser than 7. Strictly lesser than 7. So we can write n lies between 1 and 7, or 1 lesser than n lesser than 7. This can also be read as n is greater than 1 but lesser than 7. So if using these ideas, if we write it in rule method, let us use the representation form correctly. B is a set of all y, because I have taken y here. B is a set of all y such that, you know that colon means such that y is equal to n upon n plus 1. This is the form of the number n upon n plus 1. Further condition is n should lie between 1 and 7 strictly. Strictly speaking, it is 1 strictly lesser than n, strictly lesser than 7. However, you could have used 2 less than or equal to n less than or equal to 6 also would have been the correct answer. And n should be a natural number, because we see only natural numbers here. There is no other number in the numerator. There is no integer like a negative integer or 0. So all the natural numbers are visible. So I am writing them as n belongs to capital N, which means natural number. So for the moment, this is enough for our further practicing of exercises. So we will further continue with one simple exercise. Then we will continue our discussion in the theory that is called set theory. Thank you.